yes, this installation is not compliant with the National Electrical Code. Article 230.6 of the NEC mandates that service entrance conductors must be protected from both the weather and potential physical damage. Leaving these conductors exposed to the elements creates a significant safety risk. Environmental factors such as wind, rain, snow, and ice can degrade the insulation over time, leading to potential short circuits and ground faults. Furthermore, physical damage from impacts or abrasion can compromise the conductor's integrity. The exposed conductors present an increased risk of electrical shock to anyone who might come into contact with them. If the insulation is compromised and a person touches the conductor, they could receive a dangerous or even fatal electrical shock. Similarly, if the conductors come into contact with a grounded object, it could result in a ground fault and a potential fire. Exposed conductors also create a significant fire hazard. Moisture intrusion can lead to corrosion and arcing, which generates heat and can ignite nearby combustible materials. In addition, damaged insulation can create a path for current leakage, leading to overheating and potential fires. The code provides specific methods for protecting service entrance conductors. The most common and recommended approach is to install the conductors within a conduit or other approved raceway. A raceway is an enclosed channel designed to hold and protect wires and cables. Common types of raceways include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit. When installing conductors in a raceway, it is crucial to properly seal both ends of the raceway to prevent moisture from entering. Moisture can cause corrosion and damage to the conductors, leading to electrical failures and safety hazards. The sealing should be done with appropriate sealing fittings or compounds that are specifically designed for use with electrical raceways. Another important consideration when installing service entrance conductors in a raceway is to ensure that the raceway is sized correctly. The raceway must be large enough to accommodate the conductors without overcrowding. Overcrowding can lead to overheating and insulation damage, which can increase the risk of electrical fires. The NEC provides specific guidelines for calculating the fill capacity of raceways based on the size and number of conductors. Firstly, determine the correct type of raceway. The selection of the appropriate raceway depends on several factors, including the environment, the type of conductors being used, and any applicable local codes or regulations. Rigid metal conduit and intermediate metal conduit provide excellent physical protection and are suitable for both indoor and outdoor applications. Electrical metallic tubing is a lighter weight option that is suitable for indoor applications where physical protection is not a major concern. Rigid polyvinyl chloride conduit is a non-metallic option that is suitable for corrosive environments. Secondly, size the raceway appropriately. The size of the raceway must be large enough to accommodate all of the conductors that will be installed within it, as well as any necessary bonding conductors. The NEC provides tables that specify the maximum number of conductors that can be installed in a given size of raceway. These tables take into account the size of the conductors, the type of insulation, and the type of raceway. Thirdly, install the raceway correctly. The raceway must be installed in accordance with the manufacturer's instructions and any applicable codes or regulations. This includes properly supporting the raceway, making sure that all connections are tight and secure, and sealing the ends of the raceway to prevent moisture from entering. Fourthly, pull the conductors into the raceway. When pulling conductors into a raceway, it is important to use a pulling lubricant to reduce friction and prevent damage to the insulation. The conductors should be pulled in carefully and evenly to avoid stretching or kinking them. Fifthly, terminate the conductors correctly. The conductors must be terminated properly at both ends of the raceway. This includes stripping the insulation, connecting the conductors to the appropriate terminals, and tightening the connections securely. If the existing service entrance conductors are already installed and exposed, it is strongly recommended to have them inspected by a qualified electrician. A qualified electrician has the knowledge, skills, and experience to assess the condition of the conductors and determine if they are safe to use or if they need to be replaced. The electrician will inspect the conductors for any signs of damage, such as cracks, cuts, or abrasions in the insulation. They will also check for any signs of corrosion or moisture intrusion. If the electrician determines that the conductors are not safe to use, they will recommend that they be replaced. The replacement should be done in accordance with the NEC and any applicable local codes or regulations. This includes using the correct type and size of conductors, installing them in a properly sized and sealed raceway, and terminating them correctly. The NEC provides detailed requirements for service entrance conductors, including the type of conductors that are permitted, the minimum size of conductors, and the methods for protecting conductors from physical damage. Article 230 covers services in general, and specifically 230.6 focuses on the protection of service conductors from physical damage. Other relevant sections include 230.7, which covers the mechanical protection of service cables, and 230.8, which addresses the protection of service conductors from abrasion. Article 300 provides general requirements for wiring methods and materials, including raceways and cable assemblies. It covers topics such as the installation of raceways, the support of conductors, and the protection of conductors from physical damage. Article 310 covers conductors for general wiring. It includes information on the types of conductors that are permitted, the ampacity of conductors, and the installation requirements for conductors. Specifically, 310.15 provides guidance on determining the allowable ampacity of conductors, taking into account factors such as the conductor size, the insulation type, and the ambient temperature. Additionally, the NEC provides specific requirements for grounding and bonding of electrical systems. Grounding and bonding are essential for protecting people and equipment from electrical shock and fire hazards. Article 250 covers grounding and bonding requirements, including the grounding of service entrance equipment, the bonding of metal enclosures, and the sizing of grounding and bonding conductors. When evaluating the service entrance conductors, consider the following aspects. Firstly, insulation integrity. Check the insulation of the conductors for any signs of damage, such as cracks, cuts, abrasions, or discoloration. Any damage to the insulation can compromise its ability to protect against electrical shock and fire hazards. Secondly, physical protection. Ensure that the conductors are adequately protected from physical damage. This includes being installed in a raceway or other approved enclosure. Thirdly, proper clearances. Verify that the conductors have adequate clearances from other objects, such as trees, buildings, and ground. The NEC specifies minimum clearance requirements for service entrance conductors to prevent accidental contact and ensure safety. Fourthly, secure connections. Check that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to electrical fires. Fifthly, weather protection. Ensure that the conductors are protected from the weather. This includes sealing the ends of raceways to prevent moisture from entering and using weatherproof fittings and enclosures where necessary. Sixthly, grounding and bonding. Verify that the service entrance equipment is properly grounded and bonded in accordance with the NEC. This includes connecting the grounding electrode conductor to the grounding electrode system and bonding all metal enclosures to the grounding system. Replacing exposed service entrance conductors involves several steps. Firstly, disconnect the power. Before starting any electrical work, it is essential to disconnect the power to the service entrance conductors. This can be done by turning off the main breaker at the service panel. Secondly, remove the existing conductors. Carefully remove the existing exposed conductors. Take note of how the conductors are connected to the service panel and the meter to ensure that the new conductors are installed in the same way. Thirdly, install the new raceway. Install a new raceway from the service panel to the meter. The raceway should be sized correctly to accommodate the new conductors and should be installed in accordance with the manufacturer's instructions and any applicable codes or regulations. Fourthly, pull the new conductors. Pull the new conductors into the raceway. Use a pulling lubricant to reduce friction and prevent damage to the insulation. The conductors should be pulled in carefully and evenly to avoid stretching or kinking them. Fifthly, terminate the new conductors. Terminate the new conductors at both ends of the raceway. This includes stripping the insulation, connecting the conductors to the appropriate terminals, and tightening the connections securely. Sixthly, restore the power. Once all of the electrical work is completed, restore the power to the service entrance conductors by turning on the main breaker at the service panel. Regular inspections and maintenance are crucial for ensuring the continued safety and reliability of electrical systems. Schedule periodic inspections by a qualified electrician to identify and address any potential problems before they become serious hazards. During these inspections, the electrician should check for any signs of damage, wear, or corrosion on the conductors, connections, and equipment. They should also verify that the grounding and bonding systems are intact and functioning properly. By addressing any issues promptly and performing regular maintenance, you can minimize the risk of electrical shock, fire, and other hazards. The NEC is a comprehensive set of standards that provides detailed requirements for the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Familiarizing yourself with the NEC and following its guidelines is essential for ensuring the safety of yourself, your family, and your property. Consider consulting with a qualified electrical contractor for any electrical work. A qualified electrical contractor has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC. They can help you to identify potential hazards, recommend appropriate solutions, and ensure that your electrical system is safe and reliable. When selecting an electrical contractor, it is important to choose one that is licensed, insured, and experienced. Check the contractor's credentials and references to ensure that they have a good reputation and a history of providing quality work. Also, be sure to get a written estimate before any work is started so that you know the cost of the project up front. In summary, exposed service entrance conductors are a violation of the NEC and a significant safety hazard. They should be replaced with conductors installed in a properly sized and sealed raceway. Consult with a qualified electrician to ensure that the work is done safely and in accordance with the NEC. Remember to always prioritize safety when working with electricity. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Neglecting electrical safety can have serious consequences, including electrical shock, fire, and even death. By following the guidelines in the NEC and working with qualified professionals, you can ensure that your electrical system is safe and reliable.